Hey everyone, welcome back. Today we are diving into something that completely changes how you think about AI. We're talking about agent memory, why it matters, what it actually does, and why the difference between AI with memory and AI without memory is bigger than most people realize. This is episode 1 of our deep dive into AI agent memory systems. Here's a question to get you thinking. If ChatGPT remembers what you told it last week, why does that matter so much? Most people think it's just a convenience feature, like not having to repeat yourself. But the real answer goes much deeper than that. It's the difference between a tool and a colleague. Let's start with the core problem. Every time you open a new chat with an AI, it has no idea who you are. It doesn't know your job, your preferences, what project you were working on, or what you discussed 5 minutes ago in a different tab. That's because these systems were built to be stateless, meaning they start completely fresh every single time. No memory, no history, no context. To understand this properly, let's use a computer analogy. Think of the AI model like a processor, a CPU. The context window, which is the amount of text the AI can read and think about at once, works exactly like RAM. It's fast, it's powerful, but when you close the program, everything disappears. Modern AI models have enormous context windows. Some can handle 1 million tokens, which is roughly the equivalent of 10 full novels. That sounds impressive, but there's a fundamental problem. Context windows have 3 critical weaknesses that no amount of RAM expansion can fix. First, volatility. Close the tab, and everything is gone. Second, accuracy degrades as context grows longer. Research shows that accuracy for information buried in the middle of a long conversation drops by more than 30%. Third, it's expensive. Processing hundreds of thousands of tokens on every single API call adds up fast in both cost and response time. So what's the solution? Agent memory works like adding a hard disk to the computer. Instead of keeping everything in RAM, the agent stores the important information, your preferences, past decisions, project context, in an external database. When you start a new session, it retrieves only the most relevant pieces and loads them into the context window. This approach is called context engineering, and it's the core skill behind every high-performance AI agent being built today. Now here's something important that trips a lot of people up. You've probably heard of RAG, Retrieval Augmented Generation. Many people think RAG and agent memory are the same thing. They are not. They are fundamentally different, and the difference matters a great deal. RAG is like having a very smart librarian. You ask a question, the librarian goes and finds the most relevant pages from a fixed collection of books and hands them to you. That's it. RAG doesn't remember what you asked before. It doesn't learn anything from the interaction. It doesn't update the book collection based on what you discussed. Every query starts completely fresh from a static document store. Agent memory is something else entirely. Instead of just reading documents, the agent actively writes to its memory store. It records what happened, what decisions were made, and what the user prefers. It tracks time, so it knows that older information might be outdated, and newer information should take priority. It detects contradictions between stored facts and resolves them. Think of it this way. RAG is a read-only database, while agent memory is a living, evolving knowledge base that grows smarter with every interaction. When you give an AI agent proper persistent memory, 4 massive changes happen. These are not small improvements. They represent a fundamental shift in what the AI actually is and what it can do for you. Let's walk through each one. The first shift is extreme personalization. Without memory, you have to re-explain yourself every single time. With memory, you tell the agent once, for example, that you prefer TypeScript, Tailwind CSS for styling, and English code comments, and it remembers that forever. Every future session automatically loads your preferences. The friction of setup disappears completely. The second shift is cross-session continuity. Most real knowledge work takes days or weeks. Without memory, your AI loses all context every time the conversation ends. With memory, you can close your laptop on Friday, come back Monday morning, and simply say, "Let's finish the payment module we started." And the agent knows exactly what you were building, what decisions were already made, and what still needs to be done. The third shift is dramatic cost and latency reduction. Instead of stuffing thousands of tokens of conversation history into every API call, memory systems compress and store only the essential parts. When needed, only the most relevant pieces get retrieved. Studies show this selective retrieval approach cuts token usage by 70 to 90% compared to keeping full history in context. In enterprise environments, this has reduced response latency from 30 seconds down to just 300 milliseconds. The fourth shift is cognitive learning. This is the most powerful capability. The agent doesn't just remember facts, it learns from experience. If a deployment script failed because of a library version conflict, the agent stores that lesson permanently. Next time it encounters a similar task, it recalls that failure and proactively writes code that avoids the same mistake from the start. Just like a human expert who genuinely improves with experience, the agent gets better over time. Now let's look at how leading AI platforms actually implement memory today. They each take very different approaches, and understanding those differences helps you choose the right tool for your work. ChatGPT uses global multi-layer memory operating across 3 layers: explicit facts you tell it to save, automatic references to past conversations, and an inferred profile built from your behavioral patterns. The benefit is that the AI feels personally tailored across all your different chats. The trade-off is that it can accumulate outdated or conflicting memories over time, requiring occasional manual cleanup. Claude takes the opposite approach with its projects feature strictly isolated workspaces. Nothing from one project bleeds into another. You set up a project with permanent instructions. Upload relevant knowledge documents up to 200 megabytes, and every conversation in that project stays consistent. It's ideal for professionals managing multiple clients or sensitive projects, where information leakage would be a serious problem. In the developer world, Cursor and Claude Code show how memory architecture choices lead to completely different kinds of tools. Cursor is session-based, excellent for real-time autocomplete and quick edits, but context fades as conversations grow long. Claude Code works differently. It creates a physical markdown file directly in your project directory that stores architecture decisions, coding conventions, and lessons learned across sessions. Come back a week later, and Claude Code reads that file and picks up exactly where you left off. Independent benchmarks show Claude Code uses up to 5.5 times fewer tokens than Cursor on complex multi-file tasks, entirely because of this persistent memory architecture. So here's the bottom line. Memory is the single most important factor that determines whether AI stays a tool you have to reteach every session, or becomes a genuine colleague that grows more useful every time you work with it. Without memory, even the most powerful AI model is like a first-day employee who forgets everything overnight. With proper memory architecture, it becomes the experienced partner who knows your workflow, anticipates your needs, and keeps getting better. That's it for today. See you in the next one.